This is problem number 6 from the review, the projectile motion review, and it says a bullet is fired from a height of 45 meters and hits the ground 2,000 meters away. With what velocity does the bullet leave the gun? So there's a couple of assumptions that you're being asked to make in this problem. First of all, it says the bullet's fired from a height of 45 meters. So what we're being asked to assume is essentially something like a person is standing on top of a 45-meter building or a 45-meter surface and they shoot this gun, right? Okay, that gun may be a little large, but you get the idea. They shoot the gun and the bullet leaves the gun, and the bullet's going to have a trajectory that does something like this. So we're making an assumption that the gun is being shot parallel to the surface. So I'm going to go ahead and add my coordinate system in, and we also know this is one of those problems where we're going to neglect air resistance. So let's take a minute and think about what we know about problems like this. We have an x direction and we have a y direction because we have two-dimensional motion happening. In the x direction, we know acceleration is 0, and we know that because there are no forces acting on the bullet in the x direction. We're neglecting air resistance. By nature of these problems, we neglect air resistance. The only thing that's causing this bullet to actually hit the ground is the fact that there's gravity. So that means acceleration in the x direction is 0, which tells us there's going to be some average velocity in the x direction, even though we don't know what it is yet because we haven't found it and it doesn't tell us in the problem. We know that delta x is, because the problem says it hits the ground 2,000 meters away, delta x is going to be 2,000 meters, and then time in the x, which we don't know. Now in the y direction, you're probably saying, hey, we know there's acceleration due to gravity. That's correct. The only force acting on this projectile, by the way, we could draw a free body diagram of this projectile. This is what the free body diagram would look like. The only force acting on this particular bullet is gravity. So that means the only acceleration acting on the bullet is acceleration due to gravity. I made it negative because I have down as negative on my coordinate system. And then we have these velocities. We have a velocity initial in the y direction. We have velocity final in the y direction. We have delta y, which is displacement in the y direction. Extend my line here, and then we have time in the y direction. Now, here's the piece that I want you to remember. In the y direction, when you're firing something that's horizontally or like off a cliff, the initial velocity in the y direction needs to be 0. Because as this bullet continues over a period of time, it's going to be going farther and farther down, which means it's going to be accelerating or it's going to be more and more negative. So it's speeding up in the negative direction. The delta y, we're given up here, is going to be negative 45 meters. And if you're asking why negative 45 meters, it's negative 45 meters because we have down as negative. So it's like we're starting at 0 and it's going down 45 meters. And we don't know time in the y direction either. So we don't know final velocity in the y, although we could find it. We don't know time in the y, we don't know time in the x, and we don't know average velocity in the x. So the question becomes, with what velocity does the bullet leave the gun? So what you should be thinking to yourself is, when it says which velocity am I talking about? Am I talking about velocity in the x direction or the y direction? Well, the initial velocity in the y direction is already 0. So that should tell you, hey, for the record, we can't really do a whole lot more in the y direction in terms of initial velocity, but we can find initial velocity in the x direction. So this is our end goal. Our end goal is initial velocity in the x direction. So what are we going to do? Okay, so at this point you're probably saying, well, let's look at what the variables we have on the x side. We only have, for all intents and purposes, one piece of information, and that's the displacement in the x direction. We don't know time and we don't know velocity, and having acceleration as 0 really isn't helpful because there's not an equation that we can plug it into. So then look, what you do know is this is really half a trajectory of a projectile. So the amount of time it's going to take the bullet to get down to the bottom is the exact same amount of time it's going to take the bullet to get over to the point where it lands horizontally. So our times are the same, and because our times are the same, if we could find the time on the y side, we could plug that into the x side and use it. So let's look at the y side. Do we have enough information? We know initial velocity in the y, we know acceleration in the y, we know displacement, so can we find time? I'm hoping you're saying yes. So step 1, find time in the y. Time in the y can be found. If you look at your quality core equation sheets, you're probably thinking there's really only one we can use. We should be using the one that says x equals x initial plus velocity initial t plus 1/2 a t squared. Well, we know we could subtract x initial, and this really just becomes x minus x sub naught, which is the same thing as delta x, or in our case, delta y. So let's just rewrite this as delta x equals, this one goes away, velocity initial times time plus 1/2 a t squared. Now, this would be problematic, except we know, you look over here, we know velocity initial is 0. Since velocity initial is 0, this whole term is going to go away because 0 times time gives us just 0. So let's take a minute and we're going to cross that out. Now we're left with delta x equals 1/2 a t squared. So since I'm solving for t, I'm going to divide by 1/2 a, divide by 1/2 a. Dividing by a half is the same as multiplying by its reciprocal. The reciprocal of 1/2 is 2, so 2 delta x over a equals t squared, because the 1/2 a is canceled, and since it's a squared, I'm going to take the square root. For the record, that seemed to be a mistake that kept coming back to bite people. Make sure you don't forget to take the square root. So the square root of 2 times delta x. Now in this case, be careful. When I say delta x, because I'm talking about in the y direction, I just mean displacement, and displacement is negative 45 meters. Okay, so the delta x just means displacement in whatever direction you're talking about. And since we're in the y direction, we also need acceleration, which is negative 9.8 meters per second squared. So time is going to equal 3.03 is what I got for my time. So 3.03 seconds, and that works out because my meters are going to cancel, and I have basically 1 over seconds squared, which is the same thing as seconds squared, and the square root of seconds squared is just seconds. So time in the y ends up being 3.03 seconds. Now that's helpful information, because if we know time in the y, we also know time in the x. So time in the y, 3.03 seconds, time in the x, 3.03, ooh, that's a bad one, seconds. Now I can find my velocity in the x. And the reason I can find that is because now I have two pieces of information. I have delta x and time, so displacement and time, and now I just need to find velocity. Now this is one of the cases where it's okay to use this equation, change average velocity equals change in displacement over time, and the reason we can use that is because there's no acceleration. That's the only reason this equation is okay. So the average velocity in the x equals delta x, which is 2,000, so how far the bullet went in the x direction, 2,000 meters over how long it took to get there, that's 3.03 seconds. So you should get the average velocity in the x direction as 660 meters per second. And if you think about that, it's a really high number, but we are talking about a bullet leaving the barrel of a gun. So that's not that ridiculous. Now I'm going to go ahead and leave it like this. If we were doing sig figs based on the particular problem we're given, it would actually end up rounding up to 700 meters per second. But in this case, that's your answer.